presentation purposes. Yeah. To introduce myself, my name is Tammy. I'm a grade student in Biochem in CAS. And for today, I'll be discussing with you some tips in solving stoichiometry in general care. Okay, I recorded siya. And so hopefully, if you have questions, you can send them in our chat and we'll entertain them at the end of the lecture. Okay, so nakikita niyo po ba yung nakashare na PowerPoint sa ating screen? Kita po ba nila? Okay. Ayun. So, kita na po. Ayan, ayan. Okay. So please refer to our screen for the PowerPoint and we can set a file later if ever. Pero for now, please focus muna sa nakapresent. Yeah, thank you, Sir Dusty. So, sige po, next. We'll provide you an outline for today. We'll have our introduction and then the lesson proper itself. And then yung mga applications niya, debating reagent, reagent mixes, fraction yield. And syempre, for the focus for today, syempre techniques in solving problems and a case study. So you can participate later ano ba yung mga pwede natin gawin in each section. Ayan. So, what's sabi dito, in chemistry, it is very important to know how reactions take place. So, actually, sa bahay pa lang, makikita natin, di ba, our parents are cooking. So, may ingredients tayo in this case, di ba? And syempre, kung gusto natin ma-attain yung or ma-maintain or ma-obtain yung certain taste na gusto natin, we add certain ingredients in a pot or whatever you're cooking in order to get the desired amount, the desired taste, o yung nga yung umami ng food. So, sorry po, next po ata. Yeah. So, in laboratory, syempre, in the university, we have basic chemistry classes and we encounter different reactions in chemistry laboratories, or actually even in biology or physics. Pero yun, these two questions always pop up. How much product will be formed from specific amounts of starting materials or your reactants, and how much starting material must be used to obtain a specific amount of product. Hello. So, syempre, today, our topic is stoichiometry. We will answer all these things through stoichiometry. Ayan. Okay po, next. So by definition, stoichiometry is the quantitative study of reactants and products in a chemical reaction. So the method that we use is the mole method, where the coefficients are interpreted as the number of moles of each substances. Yeah. So in a reaction, for example, we have on the right the synthesis of your ammonia from your nitrogen gas and your hydrogen gas. And as you can see, when we form the general equation, it's your nitrogen gas plus 3 moles of your hydrogen gas equals to 2 moles of your ammonium. Sige po. Ayan. So, to interpret the equation, nakalagay dyan, 1 mole of nitrogen gas combines with 3 moles of your hydrogen gas to form 2 moles of your ammonia gas. Yes. So we know that merong relationship ang mga variables natin dito, specific yung elements natin dito. And as you can see on the screen, 3 moles of your hydrogen gas is stoichiometrically equivalent to 2 moles of your ammonia. So what does that mean? That means that when you have 3 moles of your hydrogen gas, you can produce 2 moles of your ammonia gas. Okay po. Ayun. So given that, sige nga, what is the relationship between your nitrogen gas and your hydrogen gas? And what is the relationship between your nitrogen gas and your ammonia gas? Okay, bigyan natin 10 seconds. You can answer sa chat natin. Sir, ayun. Ano next nyo? Anyways, ayun. Okay. Since the next na sir, it's very easy lang, di ba? Na the relationship of your hydrogen gas and your ammonia gas, you have 3 moles of your hydrogen gas. And it's stoichiometrically equivalent. We use this symbol to denote yung equivalence in stoichiometry. You have 2 moles of your NH3. Yeah. Ganun lang siya. How about your nitrogen gas and your hydrogen gas? So we just rewrite the equation, no? N2 gas plus 3H2 gas result to your 2 moles of your nitrogen. Okay? So, yung first question, nasa ko na. The second question would be, you have 1 mole of your nitrogen gas is stoichiometrically equivalent to 3 moles of your hydrogen gas. That's why in stoichiometry, this is very important because these would be our conversion factors in the long run. So, bakit natin ginawa yan? So, di ba, nakita nyo kanina sa screen, we have 3 moles of H2 is to 2 moles of NH3 and yeah, 1 mole of your nitrogen gas is to 3 moles of H2. So they can be interchanged, no, depending on what we need. Hindi po, go back po tayo sa slides. Wait lang po. Later. Ayan. So, provided on your screen is the relationship. We'll be using that for our conversion factor. Okay. Okay po, pa-next na lang po. Ayan. So, given the equation, syempre, we can have sample problems. So, actually, in stoichiometry, no, we have general approaches. Pero, let's explore them one by one. So, we have a first question here. So, for question number 1, we have 6 moles of your hydrogen gas, and we allow it to react completely with your nitrogen gas to form your ammonia gas. It says, calculate the amount of NH3 produced in moles. So, and for the second question, suppose 16 grams of H2 react completely with your nitrogen gas to form your ammonia gas. How many grams of ammonium, will be formed? And we are given the molecular weight of your hydrogen and nitrogen. Okay, next po. So, syempre yun nga, in Stoic, we have to check everything. So, check if the equation is balanced. All givens are known, all unknowns are stated, and if whether there are factors or constants that are needed to be provided. So, na-verify ba natin na yung equation natin is balanced? So, sulat natin ulit. Sorry, nabulat ako. NH. Okay. So, in this side, we have 2 nitrogen molecules, dito rin dalawa. So dito we have 6 and we have 6 hydrogens as well. So it's balanced, no? Next, ano yung pinapahanap? What are the known values? We are given the molecular weights of your hydrogen and the molecular weight of your nitrogen. This is 1.008 grams per mole. And you have your nitrogen, which is, I think, 14.0067. Yeah. Okay. Kita ba nila? Sorry, mali po. Lakihan natin. Okay. And you have your 14.0067. Yeah. So, the equation is balanced. You have your knowns. What is the unknown? So, we are looking for the moles of your ammonia gas. When we react 6 moles of hydrogen gas with your ammonia. Nitrogen gas, right? So, I think madali lang naman ito. So to give you a step-by-step procedure, yeah, later we'll be flashing out the yung magandang portion. Ayun. So, ayan. So, kanina, meron tayo equivalence factor, no? So, let's start with your 6 moles of hydrogen. So, ano lang po yung pinapahanap sa atin? Pinapahanap po sa atin ay moles of your ammonium. And kanina, we have written the conversion factor for 1 mole of your hydrogen gas. You have how many moles of your NH3? Sorry, actually 3 moles. Kasi 3 po ang nandito, right? You have 2 moles of your NH3. Yeah. So, syempre madali pa ito. For the conversion factor, ilalim natin si 3 moles, your hydrogen. And sa taas ito mo. So, canceling out, then multiply, you have 2 here. Multiply dito lang. You will have 4 moles of your ammonium gas. Check nga po natin kung correct ang ating solution. Through looking to our power. So this is 4. So lagi niyong ipa-final answer. Minsan kasi may mga kailangan na makita. Like, pag naka-box siya, it means it's your final answer. Okay, so correct naman tayo, no? We got 4 moles of your ammonia. Madali pa, no? O sige, question number 2 tayo. So for question number 2, yan, flash po muna natin sa screen. Ang gusto natin makuha from your given, you have, I think, ilang grams po yung given ni hydrogen? Pwede po ba, ibalik po natin. Hindi po kasi siya kita dyan. So for question 2. Sige po, back pa po. So yeah, okay. So 16 grams of your hydrogen gas. So, ang sabi po nito, you have 16 grams of your hydrogen gas, it would react to a certain amount of your nitrogen gas. Ang sabi sa question, how many in grams would you produce ammonia gas? So, ganun siya. No? Nakita po ba nito yung sinusunod? Sige. Sige po. So, ano po yung gagawin natin dito? What would be our first step? So we have our grams of your hydrogen gas, diba? So this is grams po, ha? So we need to convert that into moles. Kasi, that's why we had our conversion factors kanina. I-rewrite ko lang rin po ulit. You have how many moles of your hydrogen? So given the equation, sulat ko lang po ulit, binubura ko all in the day. We have 2NH3. Yan. Okay? So our conversion factors, you have 1 mole of your nitrogen gas. You have 2 moles of your NH3. Then 3 moles of your hydrogen gas. You have 2 moles of your ammonia gas. Kita pa po ba nila? Or parang maliit na? Maliit pa rin. Kita kaya natin. Titipin natin. We have 1 mole of your nitrogen gas would produce 2 moles of your ammonia. Yeah. Then you have 3 moles of your hydrogen gas would produce 2 moles of your ammonia. Okay. So let's do it step by step. So we are given 16 grams, no? Ito po yung given natin. So this is the given. So what would be the next step for this? We have our conversion factor. So we have to convert grams to moles. Moles of your hydrogen gas. From your moles of hydrogen gas, you have to find the moles of your ammonia gas in order to arrive to the grams of your ammonia gas produced from 16 grams. Tulad ko lang po ulit. Yan. NH3 Then finally, you have your grams of your ammonia. Ito po yung susundan nating approach. So 1, 2, 3, and lastly, you have your answer 4. Okay, so let's start with 16 grams of your hydrogen gas. So if you want to convert it from grams to moles, anong gagawin po natin? You can answer po sa chat. Ang gagawin po natin, we have to just multiply it by our molecular weight. Okay. So you have 16 grams of your hydrogen gas. You just have to multiply it by what? Is it 1.008 or is it 2.016? 1.008 or 2.0018? The answer is
2.06.
oh, correct. 2.016 grams per 1 mole. Bakit? Kasi we are given a diatomic molecule which is hydrogen gas. So in nature, hydrogen gas is diatomic. So ano pa yung mga ibang diatomic? H, actually your halogens, di ba? Yan, diatomic sila, your nitrogen gas. Yan yung few. Okay. So going back, yan. So bakit po nasa ilalim siya? Because we want to cancel out the grams. So, getting their calculator, sige, pwede po natin pinag-set. Please calculate habang hindi po natin binaview yung problem. Next po. Sige po, next po. Sige po. Sige po, next po. So, syempre wala pong hawak calculator, pero when we calculate this, ang lalabas po ay 7.94 grams. Sorry, moles. Moles. Pero syempre, for the sake of your solution, you can just have one here. So, okay na po tayo sa step 1. So, and actually, okay na po tayo sa step 2. So, we have most of H2. So, ano pong gagawin natin next? So you have your 7.94 moles of your hydrogen gas. So do not forget to put ano po iyan. Okay? And then we just have to insert our conversion factor. What's our conversion factor? We have 3 moles of your hydrogen gas would produce 2 moles of your ammonia gas. Okay? So you just have to cancel out, and the answer would be, sige po, pwede po natin i-next. Ako lang po nakikita nila na. Sige, sir. Next po natin. Okay lang. So getting your calculator, so this would cancel out po. Ang matitira lang ito. So 7.94 times 2 divide 3, the answer would be 5.29 moles of your NH3. So meron na tayo nito. Ano na lang next? So we just have to convert this into your grams of NH3. Okay. 5.29 moles of NH3. You just have to multiply your, ano po yung multiply natin dito? Hindi po kayo sumagot sa chat. I-multiply po natin ang kanyang molecular weight. So what's the molecular weight of ammonia? Okay, 14 plus 3 times 1.008. So to be exact, sige, gawin natin exact. 14.007 grams per mole plus 3 times 1.008. Siyempre, once you add that, this would cancel out to provide their grams of ammonia. Okay, next po yung power. So, get your calculators. Tingnan nga natin kung tama tayo. Okay, next question. Yeah, so 90.1 grams of NH3. Meron po ba nakakuha? Heart reacts naman po kung nakuha nyo. Meron po ba? Wala. Okay, very good. Dito sa mga ating students, so tayo kayo pala. Ayun. So, ako, talaga lang. Sige. Ayan, so 90.1 grams per. Ayan, I missed. Balik po tayo sa PowerPoint. We can erase this one. Yeah, okay. So the next slide, actually, this is a step-by-step process. Sir, sige po pa next slide po natin para po makita nila na the process can be done horizontally. So actually, no, in your calculator, syempre, ayaw natin yung step-by-step. Susulat mo pa ulit. So ang mangyayari, as seen on your screen, you have your grams of your ammonia gas. I-convert niya, yan, no, directly from your grams of your hydrogen gas. Minultiply niya lang ng 1/2.016. That's the molecular weight of your hydrogen. Then the fourth term, you have 2 moles of your ammonia gas over 3 moles of your hydrogen gas. That's the conversion factor or the stoichiometric equivalence. And then lastly, you just have to multiply 1 mole of your ammonia gas is to 17.03 grams of your ammonia. So that's the molecular weight of your ammonia gas. And we arrive with 90.1 grams of your ammonia. So, nakakasunod po ba? Pwede po bang mag-type ng yes? Kakasunod po. Kakasunod. Okay. It's okay. Mas maganda sana kung face-to-face. Sabi ko, I will do it. Ayun. Sige pa. Next. So typically, no, ganyan lang yung mga stoic. So you just have a general step-by-step procedure when dealing with things. Actually, especially here. So seen on your screen is the general approach to stoichiometry. So kanina ginawa natin, we started 16 grams of your hydrogen. That's the mass of compound A. And then, syempre, while conversion, we just multiply with your molar mass of your compound A to get the moles of the compound A. Then, yung conversion factor is the mole ratio of A and B. And from your balance equation, you will get from moles of A, moles of B. And then you just have to use the molar mass of compound B, just have to multiply to get the mass of compound B. Yung po yung ginawa natin kanina to arrive yung grams of NH3. So to interpret the given, when you add 16 grams of your hydrogen gas with a certain amount of your nitrogen, for example, you will yield 90.1 grams of your ammonia gas. So ganyan lang po siya. And we determine the theoretical yield using Stoich. Okay. Nakakasunod pa po. Ayun. Okay. So, we know the stoichiometry, we know na pag pinaghalo-halo natin sila, pwede natin ma-determine yung the yield, theoretically. So, in every reaction, sometimes hindi siya nagpo-proceed or sometimes, di ba, during titration, nag-over-titrate tayo, nagko-color change siya from colorless to pink when using phenolphthalein, So, it comes to the addition of certain mixture of solutions. So yung change in color, may excess ka ng base dun sa solution, that's why it's color pink na. Parang ganun siya integration. Pero to determine ano ba yung limiting reagent and excess reagent. So, para shortcut, limiting, from its name itself, it limits the reaction. It's the reactant used entirely. Basta ito po yung tatandaan ninyo when limiting reagent. It's used entirely in the reaction. While the excess reagent, sometimes we say that it's the reagent in excess, It's from the name itself, it's the reagent or the reactant that is what they call this, that is added on an extra amount. No? Added on extra to completely, yeah, sorry, yeah, with your limiting reagent. Okay? Yeah. So to give you an analogy, pwede po natin i-next slide. So I hope you can still see our PowerPoint ko, no? Ayan. Ayan. So meron kang 5 hotdogs and 4 na buns. And kapag nag-cook tayo, for example, makaproduce ka lang ng 4 bun and hotdog combination, pero may matitira ka na isang hotdog kasi kulang na yung ating buns. So it says there, no, your buns would be your limiting reagent, no? Kasi lahat ng buns na gamit natin sa reaction. And then may matitira ka na hotdog. That's the excess reagent. Ito po ba ko yan? That's the excess reagent, no? So usually yan, yun nga, excess na siya. So as you can see, no, wala na natira na bun. So lahat si bun may partner. Pero yung isang hotdog wala. Ayun, ganyan. So isa pang analogy, no? You have 14 males in a prom, let's say sa isang dance, and you have 10 females. Sige nga, pag nag-partner-partner sila, you have 10 male and female partners, pero may matitira ka na 4 males. So, in this case, no, the females limit the males who can dance, no, while you have an excess of males. So, parang ganun lang, no? When you have 14 molecules of A and you have 10 moles of B, no, you will have, let's say, for example, the product is AB. And this is our limiting reagent, no, let's say. So you have 10 of AB plus an excess of your A, which is 4A. So this is your, the desired product, and you have an excess of 4. So, naintindihan po ba yung analogy? Type naman po ng yes or mag-reacts. Naintindihan po ba? Ayan. Okay. Sige. Dahil naintindihan naman po ata nila, pwede tayo magbigay ng sample problems ulit. Sige po, balik po tayo sa PowerPoint. Kung may question po kayo, you can send later, no? Magbibigay tayo ng Q&A for yung sample problems. Baka po meron pa tayong gustong i-clarify. Kaya po mas encourage po sana namin na face-to-face dahil pwede nyo po matanong real-time dito. So, during the lecture. Sige, next po. Sige nga. Ito, let's consider a case of your hydrogen gas plus oxygen gas. Can you type on the chat box ano ang limiting reagent dito and reagent in excess? Let's give them 10 seconds. May nag-chat ba? Let's see. Ito nakita eh. May nag-chat po ba? Wala. Baka tulog na. Di ba? Anyways. Ayun. 10 seconds. Ayan. Meron. O sige, ano po ang chat niya? Tingnan nga natin siya. Nag-chat siya. Dahil naka-private, di na namin sasabihin. Okay, correct. Limiting reagent is O2 and your... Bakit may nagsabi na excess O2? Limiting reagent O2, sure. Ano ba yan? So, tingnan natin. Next, next slide. Ikita natin, no, na your limiting reagent is your hydrogen gas. So as you can see, no, on the right, you have water molecules plus O2. Actually, that is your Q na si O2 ang inyong excess reactant. Kasi may natira kang O2 sa diagram. So visually looking into your reaction, when you react your hydrogen gas with your oxygen gas, you will produce water plus an excess of your oxygen. So, ayan. So, as you can see, yeah, kita nyo na pag ganyan, kasi usually minsan sa mga DepEx may mga based on this, what is the excess reactant, ibibigay lang sa inyo is yung mga figures. So from that, kita nyo na auto lang yung meron sa product side at saka sa reactant side. Yun po ang ating reagent in excess. Actually, no, the limiting reagent and excess reagent can be determined quantitatively. We can calculate those. We can see it on the next slide po. So it says there, no, amount of product is determined by the limiting reagent. Eto, sige. Since hindi naman lahat ng chem ay computational, sometimes it's better to visualize things, no? Which is the excess reagent in this case? So you can send your messages on the chat box, no? Nagkakamali-mali po talaga tayo at some point. Ayun. Okay na ba? Ayun, may nagsagot, sir. Actually, no, kasi ako, I'm currently no, having review sessions, no. I'm currently reviewing for everyone. So, one of our proctors encouraged us to answer kahit minsan hindi natin alam or baka mali tayo. At least you tried and you have interaction, you have nag-iisip ka. Yun, no? And sometimes we fail, no, to have the answer. Pero okay lang yun, at least interactive and you learn from your failures. So yun ang tatandaan nyo. Okay, anyway, let's go back. Ayun, may na mga nagsagot na. So in this case, no, makikita natin on the screen na ang ating, after the reaction is complete, may mga lone red balls. So in this case, no, yung red balls natin ng excess reagent. Kasi siya lang yung walang partner. Siya yung excess. Ayun, siya yung single daw, sabi ni Sir Dustin. So, again. Ayun, so ayun nga, sabi ko kanina, quantitatively, the limiting reagent yields the least number of moles of the product. Yun yung sabi ko kanina na we can calculate it quantitatively. So let's consider another situation in the industry. So next po, ayun, no? Actually, this is from Chang General Chemistry. So kung nabasa nyo yan, review na lang siya. Yeah, the industrial synthesis of methanol from carbon monoxide and hydrogen at high temperatures, you will yield 1 mole of gas. You have 1 mole of your carbon monoxide plus 2 moles of your hydrogen gas to produce your methanol. Sige, next po. Yeah. So, ayan, given this, no, after the reaction is complete, meron tayong natirang carbon monoxide. So sige nga, since dami na natin tutunan, which is the limiting reagent there, which is the excess reagent. Is it your hydrogen gas or your carbon monoxide? May nagsagot po ba? Dapat ngayon, kahit with less than 5 seconds, may magsasagot na dyan. Meron? Wala? Ayun. Graphical pa lang tayo eh. Meron na po? Okay. Ayun, very good. So correct, no? Your carbon monoxide is your excess reagent and your limiting reagent na naman is your hydrogen gas. Yung next po. Ayan, no? Using stoichiometry, we can see, no, bakit siya yung limiting reagent. So sinabi natin kanina, it's a clue na your limiting reagent yields the least number of moles of the product. Sige nga po. Sige, next na po natin. So using stoichiometry, no, we have 2 solutions. As you can see on your screen, you have 4 moles of your carbon monoxide. When you have your stoichiometric conversion factor of 1 mole of carbon monoxide is to 1 mole of your methanol, you will yield 4 moles of your methanol. Pero, as we can see, when we have 6 moles of your hydrogen gas, no, you have 2 moles of your hydrogen gas, and 1 mole of your methanol, it would produce 3 moles of your methanol. Tama ba to or kulang siya? Wait lang okay. Okay. So, ito pong mga 4 moles of carbon monoxide and 6 moles of your hydrogen gas. came from the figure a while ago. I-back lang po natin ng konti. Until po dun sa mga may mga figure. Ayan no, nakita natin no, at the start of the reaction, you have 6 moles of your hydrogen gas. Sige sir, lagay lang po natin. Diba? Tapos 4 moles, pwede nyo po ako i-give of your, ano po yun? Carbon monoxide, no? Yan no, this is before the reaction, sabi before. Pero, when they mix, ang sabi po niya, you have how many moles of your product? 3 moles of your methanol. That's an excess of, yan, lagyan natin. 1 mole of Oh, sorry, this is not carbon dioxide. This is carbon monoxide. Yan. Yan, before, after. Sorry. So ito lang po siya, no? And we have said na, for example, you have 4 moles of your carbon monoxide. You have your factor of, based from our reaction, we have CO plus H2, no? Tama ba? CH3? Correct. H. Yan, no? 1 mole of your carbon monoxide is equal to 1 mole of your CH3OH. Yan, no? Will cancel out. You have 4 moles of your methanol. Pero, nung ginamit natin ito, 6 moles of your hydrogen gas, you have your factor, you have 2 moles of your hydrogen gas, and it's equivalent to 1 mole of your methanol. You know, just have to cancel. This is 2. I'm sorry, this is 3. Yeah, so 3 times 1. You have 3 moles of CH3OH. Therefore, H2 is the limiting. Yan, ipilitin. Diba? Simple lang siya. For now, simple. Mamaya sa sample problems, baka mabigla tayo. Pero yan lang po yung basic fundamental steps in determining which is the limiting reagent and the reagent indexes. Nakaka-follow po ba? Can you send a like, heart, or yes sa aking chat? Ngayon naman po ba? Pag may magulo po or may hindi maintindihan, send po kayo later after, before po tayo mag-sample problems. Okay. Malapit na pala ang aking end. 5 minutes. Sige po, next slide po, sir. Next slide po. 5 minutes. Ayun, sige po. Ayan. Okay. Ayan, so, sige, pasandahan na lang natin. Siyempre, in every chemical reaction, we have our reaction yields. So, di ba minsan, kahit sabihin natin, ito yung maproproduce natin na certain amount of, let's say, base or let's say, a salt, pero hindi naman entirely siya lumalabas kapag winay na natin siya sa beaker, or, sa analytical balance. So, kaya tayo pinapakuha ng reaction yield. And the formula would be the actual yield over theoretical times 100. So, in problem solving, minsan binibigay yan either of the one, and then you just have to equate the equations. So, yun nga. When do we usually use this formula? Kapag minsan we want to know the purity of your extract kunyari, or residue in a problem, no? Ayun. So, tandaan nyo lang yan, madali lang yan, basic math lang yan. Y equals to A over T times 100. Sige, next. Ayan, okay. So, last on my part, no, doon tayo sa applications. So, worldwide, no, we know naman fertilizers help crops, no, in, to produce crops that are efficient and would yield a lot of products. So, ayun, nandiyan na rin naman yung description. Next po. Ayun, no? So it's just says there, no? Nitrogen fertilizers contain nitrate salts, ammonium salts, and other compounds. So, syempre, yung plants natin, no, they absorb nitrogen. Pero, from the nitrates. Pero syempre, we have, but the ammonium salts must first be converted to nitrates by the action of soil bacteria. Yan. Yan. So, ganun. Binasa ko lang actually. Then, ayun nga. So, yung ammonia mo, industrially pala, ganyan lang siya prepare. Madali lang. You have your hydrogen gas and your nitrogen gas to produce your ammonia. Pero, ayun nga, no? Meron pa kasing iba tayong kailangan na i-prepare. Ayun, makita po natin sa next slide. Ayan, no? From ammonia, no? Ammonium and nitrate salts are prepared via this reaction. So, sige nga, ano pong reactions ito? Anong type of reaction? Is it redox? Is it organic reaction? Anong reaction yan? Pwede po kayo mag-chat. Actually, no, you have acid-base reactions. Kasi you're producing salt. Acid, you have your, dun sa first line, no, you have your ammonia, which is aqueous, plus your nitric acid to produce your ammonium nitrate. Sige. Ayun lang, no? So dito naman, no, it just says na you can produce ammonium sulfate via 2 steps. So you have your ammonia gas plus your carbon dioxide gas. Actually, it's not a gas pala. It's in aqueous form. Plus your carbon dioxide plus water would produce your ammonium carbonate. And your ammonium carbonate will be reacted with your calcium sulfate to produce your ammonium sulfate plus calcium carbonate. Sige nga, which are the limiting reagents produced in ammonium sulfate? Sige, next yun na lang. Dahil, this is a trivia lang, no? Pero if you are practical, siyempre ang limiting reagents natin, yung mga pinakauna. So sabi dyan, your ammonium and your carbon dioxide made the limiting reagents because they are way cheaper. So ayun rin, no? Bakit sila ang cheaper? So for example, you are mixing something. Let's say A is way expensive than B. So when you react them to form this, for example, syempre, we want A to be fully consumed. So syempre, ano po yung dadagdagan natin? Is it A or B? Let's say, given na mas mahal si A isa kay B, ano po yung dadagdag natin? Sige nga, Arjan. Anong dadagdag? A or B? Mas mahal si A, ha? We want to produce this, pero mas mahal si A. So ano yung idadagdag natin? Correct, B. Kasi, in a reaction, we want to fully consume this to produce ito. Okay? Ito lang siya. Tama eh. So we want to have excess of B to produce this. Para lahat si A, hindi sayang. Yan lang. That's the lecture part. Do you have any more questions before we move to the sample problems? Pwede po kayo mag-send sa chat. Meron po ba silang katanungan? May questions po ba? Correct. May nagsagot ng okay. May tanong po ba? Kung wala naman, we can give the floor to our next tutor. He's also a student in Biochem and ayun, kasama natin po siya today. Let's welcome Kuya Arjan. Arjan.
Hello po. Ako po si Arjan po, and I'll be discussing sample problems po in terms of stoichiometry to further enhance your ability to solve stoichiometric problems. So for the first problem, so I'll read it muna po. So how many copper atoms are present in a piece of sterling silver jewelry weighing 33.24 grams? Now, sterling silver is a silver copper alloy containing 92.5% silver by mass. So in terms of solving this problem, we first have to know kung ano yung hinahanap natin. So, next slide po. So, ano yung mga given muna? Actually, yung mga given natin is yung mass ng jewelry, which is 33.24 grams. And since silver, copper, alloy kasi sterling silver, we want to know, and since so, tulad mo natin. So, yung mass is 33.24 grams. And we want yung how many copper atoms yung nandoon sa ano. So, ito yung hinahanap. Yung number of copper atoms natin. Pero we're given yung percent silver ng ano. So, we are given the percent silver, which is 92.5%. And since ang hinaharap natin is copper, we want yung percent, instead of percent silver, we want yung percent copper. And since we know na silver at copper lang naman, so if the whole sterling silver, the whole 33.24 grams is 92.5% silver, then obviously yung if we take this as 100%, if we subtract 92.5% Ag to yung mass, then obviously yung percent copper would be just 100% minus 92.5%, which is equal to 7.5%. So, di pa naman kailangan, it's just arithmetic. Just subtract, and you'll find the percent copper. So, this is now the percent copper. So, next we're going to do is, since alam natin percent copper in the sterling silver or jewelry, next we're going to do is, okay, natin yan. Okay, so now we have percent copper, and that's 7.5%. So obviously, to know the number of copper, we need the mass of copper in the mismo sterling silver. And that is, can anyone, type actually, kung ano yung, paano kinocompute yung, paano kinukuha rather, yung mass ng copper sa buong mass ng sterling silver. Okay.
2.493 now.
And the method of how to do it is just by taking yung, I think tama, since it's just by taking yung amount, so mass ng copper in the sterling silver would be just multiplying 0.075, which is yung 7.5%, times yung 33.24 grams. Since sinabi nga natin na 7.5% of the total mass is the mass of the copper. So, mass of the copper is equal to, yes, 2.493 grams. 2.493 grams. So, ganun siya kinukuha. So, now, since alam natin yung mass ng copper, we actually can use now stoichiometry para malaman kung ano yung number of copper atoms. So, okay, we have now mass of copper. So, pwede natin purahin. So, mass of copper is equal to 2.493 grams. So, take note lang of the number of significant figures. Very important yan sa buong chemistry course na laging nagpropagate kasi yung error or mas tumataas yung error kapag hindi mo take account of significant figures. So always remember to take account of significant figures. So, okay, coming back, mass of copper is 2.493 grams and we want to know the number of copper atoms. But to do that, we need to know first the number of moles of copper atoms, since yun yung direct way para malaman kung ano yung number of carbon atoms. So, in order to do that, we divide, ano yung method para malaman yung from the discussion kanina? Yung amount of moles of copper.
Copy daw dito, get the number of moles present.
By how?
By how?
Like, paano siya kukunin? Like, from the mass of copper.
So, ang ginawa niya, minultiply niya by divide the mass percent by the atomic mass.
Mass. Okay, pwede naman. Yeah, so mass of copper and divided by the atomic mass to get the moles. So, there's the moles of copper is equal to 2 point, mass of copper over atomic mass of copper, which is just equal to 2.493 grams. So that's copper over, I think 63.54. Yes, 63.54 gram per mole. Now, technically speaking, paano mo malalaman kung tama po yung sagot mo? Well, if you take account dimensional analysis, this very important tool para sa stoichiometry. If you take account, if you take account dimensional analysis, if you divide gram per mole, it's just equal to multiplying gram to mole per gram. And since nasa taas to, nasa baba to, you can cancel it out and you get mole. So tama yung ginagawa mo. So, yun na, para to check if tama yung ginagawa mo and hindi ka nang masasayang ako. So, okay. I think the sagot is 0.03924. Yeah, 3924 moles. But of course, since hindi ka pa tapos mag-compute, always remember na wag mag-round off. Don't round off just yet. Kailangan i-stick mo lang dyan and just use answers calculator mo to get or i-direction mo na agad. It's up to you. As long as you get the right answer naman, okay lang yun. So, after you get the moles, to get the number of copper atoms, anong kailangan gawin? Can you type in the chat box kung paano kinukuha yung number of copper atoms?
Multiply the moles by the Avogadro's number.
Okay, good. So yung moles will just multiply with by the Avogadro's number. So always remember constants kasi usually hindi binibigay yun. If I remember correctly, like sa mga exams, hindi talaga binibigay ang constants. So good tip is to remember constants. So constant ni Avogadro's number is 6.022 times 10 raised to 34. So we multiply, lalagay ko lang dito itong buong to. Pero like I said, don't round off. So mole times 6.022 times 10 raised to 34 number of copper or copper atoms per mole, per 1 mole. So magka-cancel yung mole and you get the number of copper atoms, which is 0.2 times 10 raised to 34. That's 2.363 times 10 raised to 33. And that is number of copper atoms. And that would be your final answer.
Sir Arjan, raised to 34 po ba or 23?
Yeah, sorry, that's enough constant. Sorry. 23, right.
Ayan. So,
Yeah, sorry, 23. Sorry, naano ko siya sa Planck's constant. Sorry. Okay. Okay, and 22 pala rather. So, same number pero raised to times 10 raised to 20 copper atoms. So to check, technically speaking, since one mole daw is 63.54 grams and you have 2.493 grams, dapat technically, kung meron kang 63.54 grams ng copper mismo, then you have 6.022. So since less than siya compared to 63.54 grams, then obviously bababa dapat yung value number of copper atoms mo. So, technically, tama naman. Any questions in the execution or analysis or or the method kung paano ginawa siya? Obviously, madaming methods on how to solve this. Basta, like I said, as long as you have the right answer, kahit paano siya kinuha, doesn't really matter.
None daw po.
None. So, medyo hihirapan natin. Since dito kasi, walang any chemical reaction involved. You just have a mass, then to convert lang natin siya using stoichiometry. So, walang any reactions. You didn't use any limiting reactant. Wala nang ganun. So, medyo iangat natin yung level. Pero kaya pa naman. Like, okay. Okay, so for the next example, azobenzene can be prepared from nitrobenzene by reaction with triethylene glycol in the presence of zinc and potassium hydroxide. In one reaction, 0.10 liters of nitrobenzene, rho is density, by the way. So rho is equal to 1.20 gram per milliliter and 0.30 liter of triethylene glycol, and yung density niya is 1.12 gram per milliliter, yields 55 grams of azobenzene. What is the percent yield of the reaction? So, obviously, ang overwhelming niya, like ang dami mong hinihingi. So, by the way, since I think yung iba sa inyo nagtitake na ng organic chemistry, there's one experiment sa organic chemistry that deals with azobenzene. So, azobenzene is technically used as dyes. Yung mga kulay actually ng damit or pantalon, actually, mga denim. Yung ginagamit actually doon is azobenzene compounds. Yung azodies compounds. Just a trivia. So, in order to solve this, don't take account yung sinasabi sa taas, reaction lang naman yun. Since binigay na rin naman actually yung reaction for you. Sulat ko lang. Okay, so C6H5 NO2 plus C6H14O4, right? Yields azobenzene is H5N2 plus C6H12O4 plus water. Dito ka nilagay sa baba. C6H12O4. Ano ba? O4 plus water. So, okay. So first, since may reaction ka, the first thing you need to do is to check if balanced ba yung reaction mo. And nilagay ko rin naman sa PowerPoint, hindi talaga siya balance. And I leave it to you to check kung balance nga ba siya hindi. Para alam na rin kung paano i-check kung paano hindi balance. Titingnan niyo lang naman, for example, yung carbon mo, 6 carbon dito and 6 carbon dito, dapat 6 plus 6, so 12 carbon on the reactant sides, and by the law of conservation of mass, dapat 12 rin dapat. Pero we can see here, 6 times 2, that's 12 plus 6, so 18 na siya. So, unlike yung mga reactions na binigay in the lecture side, this type of reactions, ang dami mong i-take account na mga elements. So, natutunan kong way of doing this is by creating systems of equations para ma-solve yung coefficients nila. So, actually, nilagay ko yung mga system of equations na nakuha ko from this reaction, pero I'll tell you how. Basically, you take one element, for example, carbon, and you take how many carbon, and lagyan natin sila actually ng coefficients, ng arbitrary any coefficient actually. So, lagyan sa A, B, and then ito, lagyan ko ng C, D, tapos E. So, any arbitrary coefficient pwede. For example, for carbon, you have 6A. Since Kung ano man yung coefficient na to, multiply lagi dito kay carbon. And same with B, so plus 6B equals, since dapat equal sila, like I said, law of conservation of mass says na dapat kung ano yung number ng moles dito sa side na to, dapat equal lang dito. So dapat equal lang sila. 6A to 6B equals C6 times 2, so that's 12. C 6B, medyo, ito ay, I don't recommend this by the way, kapag gumagamit, kapag, kunwari, yung kaninang reaction yung sa ammonia. Kapag ganun lang, don't do this. Mas mahihirapan pa kayo. Pero kapag madami na yung this is kapag 3 or more na yung 3 after 4 or more elements na yung nakikita mo sa reaction, do this method after. So plus 6D, so yan na yun for carbon. For hydrogen, let's see, 5A plus 14B plus, that's 2 times 5, so that's 10C plus 12B plus 2E. And then for oxygen, okay, for nitrogen, muna, and following this lang. So that's A plus, wala naman dito, so A is equal to 2C, since 2 dito, so may dalawang N, mo multiply to 2, and then multiply to C. And then the others naman wala. So A is equal to 2C. So you're kind of getting yung mga system of equations sa agad, yung mas mabibilis na ito, mabilis sa agad, A is equal to 2C. So anything you multiply by A, kanang 1, that's equal to, for example, 1 is equal to 2C, so C is equal to 1/2, parang gano'n. So mamaya, gagawin natin yung kung paano yung solve siya. Then, for oxygen, dito, meron kang 2A plus 4B equals, wala ditong oxygen, and then this one is 4B plus E. So medyo nakakaba, actually, pero madali lang siya actually if titingnan mo siya this way. For example, if you look at nitrogen, that's A is equal to 2C, we could actually substitute it here. Bakit? Kasi if you substitute, for example, again, let's say na 1, then this is 2, this is 3, and this is 4. For example, if you substitute A for 2C, you get 6 times 2C, that's 12C, plus 6B equals 12C plus 6D. 6D. And you can see na 12C and 12C here, magka-cancel out lang sila. So you get 6B is equal to 6D, and then you're left with B is equal to D. So, anong sabihin nun? Kung ano man yung coefficient na ilagay mo dito, equal lang siya sa coefficient na to. So, mabilis lang. Makikita mo na kaagad siya. So, since meron ka dito, look for other things na kaya mong mag-substitute. What else? Okay, so this is A, this is 4B, this is 4D. Here, so B is equal to D, so this is 4B and 4D here. You can actually substitute this value, B is equal to D, and you get 2A is equal 2A plus 4D is equal to 4D plus E. And eventually, matatanggal ng dalawang to, and you get 2A is equal to E. Okay, so 2A is equal to E, A is equal to C, and D is equal to D. So, so ang method lang dito is relating, since A is related na to E and C, it's just a matter of relating A with one of the two, B or D, since B is equal to D. So hanap ka lang ng way. Actually, pwede na to. I think pwede na yata. Hindi, bawal kasi doon yun yung ginamit mo. B is equal to D here, and then E is equal to A. Okay. 2A is equal to E. 2A is equal to E. I hope na-follow niya siya. Medyo mahirap siyang follow up or nakakalimutan na. Pero like 2A is equal to E, you can relate E and C. Actually, if you relate 2A is equal to C, makuha mo dito na 2A is equal to 4C. So, ibig sabihin, since 2A is equal to A and 4C, you can get E is equal to 4C here. So, para sa yun, you can actually substitute all of those. Yung B, matitira na lang dito, either B or D, pero yung A at E, pwede lang makuha yung C. So, from here, dito ba?
Kylie.
Sa side na to, you can see na parang 5 is equal to 5A. A is equal to 2C, right? So, that's 10C na. 10C plus 14B. Okay, tira natin yung B instead of B. Equals 10C. C is equal to just C. 10C plus 12B, since B is equal to D. And then 2E. So, E is equal to 4C. So, that's 2 times 4. So, that's 8. So, plus 8C. You can see na 10C here and 10C here, cancel out na lang sila. Since pareha silang sa both sides of the equation, and you are left with 14B plus 12B. It's 14B here and 12B here. You can actually take one of them and subtract, actually, transpose ko na, so 14 minus 12, that's 2B equal to 8C. And then you're left with B is equal to 4C. So, what does this mean? So, nakarelate na siya actually. Since B is equal to 4C, D is equal also to 4C. So, whatever value of C is, let's say, arbitrarily, 1 yung value ni C, lowest number, actually 1. If C is equal to 1, nakikita natin na A is equal to 2C. So, A is equal to 2 times 1. And then B is equal to D is equal to 4C, which is 4. So 4 times 1. And then E, sabi rin natin, is 4C. So E is also equal to 4. So the balanced chemical reaction for this, if we take account of every single one, tinake accountan natin lahat, medyo nakakalito, I know. Pero if na-master mo to, actually, mas mamadali yung buhay mo in terms of like balancing equations na 4 or more yung elements na meron. So, C is equal to 1, then this one is 1, and A is 2. D naman, and D are 4, and E are 4. So, not the 4. This one and this one. And you can check actually if tama yung sagot mo. This one is 12, and this one is 24. So 12 plus 24, that's 36. This is 12 plus 24, 36. Actually, if you check all of them, balance and half. Yeah. So the balanced chemical equation would be balanced chemical equation would be 2C6H5NO2 plus 4C6H14O4 yields C6H5N2 plus 4D2 and 4D. So, yeah. Now we have balance. So, makakuha talaga kayo ng stoichiometric problems na ang haba yung equation pa lang, yung balancing pa lang na equation, ang haba na ginagawa mo, ang tagal na ginagawa. Pero if you mastered itong ability nito to make systems of equations and solving it, mas mapapadali yun. Imbes na, okay, nag-multiply ka dito, and then babalik ka doon, and then babalik ka dito. So, mas nakakalito yun actually. Pero, applicable, like I said, applicable lang to if there are 4 or more elements in the chemical equation. Kapag konti lang, hindi lang gawin ito, ganun lang kayo. So, any questions ba in the balancing? Hindi ko alam kung first time you learn itong method na to. Honestly, di ko alam.
Arjan.
Okay. Ano lang? Gets ko, ang hirap talaga. Kasi mahirap talaga itong problem to. Pero yeah, since balance na equation, you could try it on your own in your own time. Pero yeah, yun yung method of how you balance equations na 4 or more yung elements. So since balance na yung equations, now we solve, now we determine yung problem. So when you analyze the problem, usually what I would like to do after balancing the equation is magsisimula ako dun sa dulo. Like ano ba yung hinahanap natin? Percent yield. Ano ba yung formula for percent yield or reaction yield? The percent yield is actual yield over theoretical yield times 100%. And since actual yield is 55 grams, sabi naman dito, 55 grams azobenzene daw yung, sabi yields 55 grams azobenzene, 55 grams azobenzene, then meron na tayong actual yield. So all we need to do is determine yung theoretical yield and we are done. Like, mag-divide na lang tayo and then mag-multiply yung 100%, and then you're done. So, paano yun? Yung theoretical yield. So, yung gagawin natin. Medyo mahirap. Okay, so first, since alam natin yung kailangan natin, yung theoretical yield, mababawasan na ngayon yung given natin. Mababawasan na ngayon yung tinitingnan natin dun sa problem. So first, we need, in one graph on 0.10, so we need to first, since in liters actually, so hindi naman kasi volumetric yung problem natin. In analytical chem, na matutunan yun, kung when. Pero, in analytical chem, we call these problems gravimetric kasi we're talking about masses and moles, hindi naman liters. So, since meron tayong given na liters, and we need to determine mass, kailangan natin i-multiply sila first by the density. So yeah. So first, we have liters, for example, 0.10 liters nung nitrobenzene, and we have yung kanyang density, 1.20 grams per ml. So since hindi nagtutugma yung units natin, kailangan natin convert one or the other. So mas madali mag-convert ng liters to ml since mas malaki yung liters kaysa kay ml. So we need to convert this 0.10 liters since mas malaki nga siya. So converting it, actually just 1 liter, sa baba lagi liter yung kailangan mo i-cancel, is 1,000 ml. And that's roughly amounting to 100 ml, I think. So 100 ml, and then since parehas sila ng unit ng gram per ml, we just multiply 100 ml to the density, which is 1.20 gram per ml. Which is about 120 grams. So, di na ako nagka-calculate kasi I just moved, since 100 ko, moved ko lang siya 2 decimal places and few days ago. So, 120 grams. So, meron lang tayong grams, and we do the same for the other one. Since we're given liters for the other one. So, first, 0.30 liters, convert it to ml para same sila ng unit. That's 1,000 ml per 1 liter, cancel both, and then you're left with 300 ml, and then 300 ml multiplied by the density, which is 1.12 gram per ml. So cancel ml, then then multiply by 3, that's about 336 grams. So binove ko lang rin and then minultiply ko siya by 3. So ganun yung parang short component. Pero if you use a calculus, same rin naman po ako. So now we have ito. This one is for, I think this one is for nitrobenzene. And then this one is for triethylene glycol. So, okay. So, now, determining na tayo. Since meron na tayong grams, we can determine now yung limiting reactant. Since meron na rin tayong stoichiometric ratio ng reactants natin. So, let me just erase this para i-focus na lang yung Okay, so 120 grams of this C6H. Tama, no? Tama, right? C6H5NO2, this one, this is nitrobenzene. And then this one, 336 grams of C6H14O4. This one is triethylene glycol. So, 120 grams, we convert this first to moles. So, ang technique ko dito would be, paano yung makahanap yung limiting reactant kaagad, is to convert each one to moles, and whatever one is less than the other, okay, actually, yeah, whatever one is less than the other, yun si limiting reactant. So, what do I mean by that? Well, first, if you convert 120 grams to moles, that's just that's just 123.12. So 120 divided by 123.12. Correct me if I'm wrong lang. 120 divided by 123.12. That's 1 mole is equal to 123.12 grams. Ito yung molecular weight ni nitrobenzene. So, by computing it, you get 0.9747 mole. And roughly, always, at a rough estimation lang to, so wag nyo pa rin round off regardless kung nilagay ko lang dito para to show you. Pero technically speaking, you don't round off kagad. 336 grams, so that's actually ang ginawa ko actually is kinonvert ko na one of them into grams of the other. So for example, in my PowerPoint, kinonvert ko muna tong C6H5NO2 to grams of C6H14O4. So any method works. Depende lang sa'yo kung ano yung what you choose, kung ano lang yung mas appropriate for you. So convert ko lang tong 336 divided by 6 times 12.01 plus 14.08 plus 4 times 16. That's roughly around 2.237. So I think, wait. Okay, wait. 150.172 grams per 1 mole nitong C6H14O4. So when you compute that, makukuha mo actually is 2.237 moles. So as you can see, since dapat equal nga sila, kung equal sila, and then there's no limiting reactant at all. Pero we can see here na significantly lower yung moles ni nitrobenzene compared to triethylene glycol. So obviously, from here pa lang, makikita mo na si nitrobenzene na yung limiting reactant. So whatever, like I said, whatever works for you, yun yung gawin mo. Any method is parang okay naman as long as you don't cheat. Any method works, as long as any method you choose works, pwede yan. So ito yung excess. So now, since ito yung limiting reactant, ito yung convert natin to the percent yield. Ito yung makukuha ng theoretical yield natin. Okay, so from the theoretical yield, what we want actually is azobenzene, this one. What we want is this one. Kasi nga, ang binigay sa ating actual yield is azobenzene. So from our moles, I'll just write this, pero since, like I said, don't round off mole, yung 0.9747 moles, since ito nga yung limiting reactant natin, ito yung convert natin from here. So, as you can see, 2 moles of nitrobenzene is 1 mole of azobenzene. So, we write itong so it's 2 moles of this one, tapos 1 mole, write ko na rin yung para hindi nakakalito, H. 5N 2, and then this one is C6H5NO2. So this one would cancel this one, and then matitira mo, you can see naman na 2 moles. So mga kalahati, basically yung sagot mo. And okay, so divide lang by 2 to get, like, and remind ko lang, don't simplify yet or don't round off yet. So this one is moles of C6, C6H5N2. So this one, ito na yung magiging sagot. Yun na yung moles ng C6, and we just convert this one for 873 moles. Convert this one to its actually one mole. By multiplying, you can just convert this one to grams. Since grams na yung binigay natin ang actual yield, we just convert this one to grams of azobenzene para makuha yung basically theoretical yield. So the molar mass is 0.1271 plus 5 times plus 14.3. So that's around 91.11 grams. So multiplying yung kanina, uh, 91.11 grams, you get around 44.40 grams of azobenzene. C6H5 and 2. Pa-check if ito rin yung nakukuha nyo. Oh, sorry. I forgot na mag-multiply ng 2. Actually, sorry. I-multiply actually ito by 2 since every single one is multiplied by 2 here. So, technically speaking, yung 91.11, what we need to actually get is 182.22 and 88.80, sorry, 88.80. Pa-check if tama yung nakukuha. Okay, 88.80 rin yung nakukuha nyo. So, tama naman. So, based on my, tama rin, 88.8. And this is basically the theoretical yield. So, now that we have the theoretical yield and given na rin actually yung actual yield, so we can erase this na. Okay, so ang mahalaga na lang dito is yung 88.8. So still, don't, it's very important na wag niyo pa rin kung ano yung nakuha niyo, wag niyo pa rin round off. Yes, thank you. Wag niyo pa rin i-round off. So, yun pa rin yun. So, ano yung nakuha niyo, wag niyo pa rin i-round off. So, percent yield is equal sa actual over theoretical. So, laging ganito naman. So, times 100. Then, so, actual is 55 grams. So, yung sinipinigay. And then this one is 88.80 grams times 100. Obviously, makakancel yung grams. Wala namang unit. Any percent ko lang unit naman. And then you're left with 55 times 100. You're left with 61.94%. Yeah. And that is yung final answer. 61.94% yield yung nakuha ko. So same ba yung nakuha yung answer or pero yeah, yun nga. Sa ginawa ko lang 62 since technically pag nire-report mo yan, parang niyalagay mo lang 62%. Yan na yun. Parang close naman to 62%. So sinasabi mo na lang when you report this in, for example, research or studies, sinasabi mo lang 62% yung yield mo. And that's fine naman. It's up to you. Up to your prof kung multiple choice yung kanya. But yeah, so far, any questions ba? I think yung most of the questions would be doon sa kung paano mo sinusolve or pinukuha yung balancing. Pero like there's not much to explain there, basta make system of equations based on the elements na nakukuha mo and their numbers na katabi nila. So, and make arbitrary or parang mga letters, parang arbitrary letters, coefficients para to signify system of equations. Ganun lang tayo. So, yeah. Any questions po ba?
Wala po, sir.
Okay, thank you. Okay, so for the last one, I think overstand na nga, pero okay, for the last one, a 99.8 ml sample of a solution that is 12% potassium iodide by mass, and ito rin naman, may density na naman, 1.093 gram per ml is added to 96.7 ml of another solution that is 14% this is lead nitrate by mass. And ito yung density na niya. How many grams of lead iodide should form? So, ang hirap naman ang binigay. Okay, so given na yung reaction, so sulat ko lang rin, EbNO3. So it's a good thing na balance na yung reaction. Yes, ayaw ko mag-balance din. PbI2. So, PbI2. So, ito yung gusto natin, yung react from the problem, yung gusto natin, plus 2KNO3. 2KNO3. And it says they're balanced na. So, from there, gusto natin is mass of the PbI2 produce, yung nag-form from the reactant. So, technically, gusto natin, from the problem, it says 12% Ki, yung sample. So technically, you need to multiply actually yung percent by mass kasi. So, you're given, for example, 99.8 ml of the sample. So, since volumetric pa rin siya, may volume ka, may density ka, and sabi dito, by mass. So, by logic lang, ang gusto natin is grams instead of ml. So, we need to convert yung 99.8 ml of the sample to the grams of the sample. So, first, multiply it by the density, 1.093 grams per ml. And that is equal to 109.08 grams. But sabi dito, yung Ki daw, in the sample, yung Ki daw is just 12%. So, whatever you got from here, you just multiply 12% to it. 0.12. And you get 13.0809 grams. Yeah, 0.9 grams. And this is grams of Ki. Ito na yung Ki in the sample. Whereas, yung naman, you have 96.7 with another solution. So that's 96.7 ml of the other solution naman daw. And that other solution has 14% PbNO3 by mass rin. So you can't really use this to compute to get yung percent of PbNO3. So you need to convert this first to grams. So same procedure, you multiply it by the density 1.134 gram per ml, and then same procedure, this would give you grams. So since you have grams, you multiply it by yung 14%, so 0.14. So getting that, actually, nakalagay natin yata 15.3616. Pasabi lang, if hindi yun kung sagot, I think ito yun, grams of PbNO3. So I think yan yung sagot, 56.2616. So same, nakukuha nyo, good. So now, since gusto natin kung ano yung nagpo-produce, kung sino yung nagpo-produce ng PBI2, we need to determine the limiting reactant from these two. Sino yung sa kanila, yung ano. So, by converting them to moles, kung equal sila, then there's no limiting reactant. Whichever one's lesser is the limiting reactant. So, first, 13.09 grams KI. Just multiply it by the conversion factor, 1 mole is to yung molar mass ni KI. So that's 13.9 and then divide by KI is around 300, sorry. Also 40.09 tier 1 sorry, plus 122 point, I think 122, yeah, or 122. Ano, can someone type in the chat kung ano yung molar mass ni KI? In my problem kasi, kinonvert ko yung gram yung mass ni PBNO3 to mass of KI. Pero, since I'm older, I'm wiser, huwag na natin gawin ito. Moles na lang usapan. So,
166.002.
166.002. 166.002. And that will give you 0.0166.002 or 0.
00.
Oh, 00. Thank you. Grams. And that is equal to 0.06354 gram mole. Whereas yung PBNO3 naman, 17 times 1.134 and 0.14 all over I think 331.22. That gives you, kung ano man to, 15.3616 grams PBNO3 times 1 mole all over 331.22 grams. That gives you around 0.046 35. So as you can see, significantly lesser itong PBNO3. So we can safely say na si PBNO3 is the limiting reactant. Follow ko ba? Okay. Nakaka-follow nyo? Like, so kinukuha ko lang yung moles since dapat, ang idea here is that if equal yung moles ng reactants natin, then there is no limiting reactant at all. Whichever one is lesser, whichever moles is lesser of the reactant, yun yung makukuha natin. Yun yung ating limiting reactant. So since lesser to, compare doon kay KI, then yung limiting reactant natin will be this one. So, okay, so from here, we just now convert yung gusto nating product, which is PBI2. Okay, we can erase this na, hindi naman na kailangan. Only ano natin is this one. So from here, we need to convert PBNO3 to PBI2. So that conversion is just moles PBNO3. So nakita natin from here, 1 is to 1. 1 mole PBI2 and then 1 mole PBNO3. So that is just equal to 0.04635. Since equal naman sila, equal rin yung kanilang moles. And then, since we now have the moles of PBI2, we convert that to grams. Since gusto nga natin how many grams of PBI2 should form. So moles of PBI2. So this is easier kasi nga hindi naman natin pinukuha
yung percent yield. Kinukulang natin is yung theoretical yield with PBI2. So 0.04635 moles of PBI2 and PBI2, I think, 461.008. Thank you. 461.008 grams of PBI2. PBI2. Okay, and then that is just equal to 461.008, 21.37 grams PBI2. So ito yung theoretical na ma-form mo from reacting yung binigay na reactants. Yeah. So any questions kung paano sinolve or sa other problems rin? Diba? Wait, what? Kasi hindi ko kasi what? Okay. Two moles. Kasi ang limiting reactant natin si I2 as KI here. Okay. Let me redo lang yung calculation. Sorry for some delay. That's 1.093 and that's 0.12 divided by mass ni KI is 166.002. Okay, wait lang. And then the other one should be 96.7 times 1.134 times 0.14 divided by 3 to 1.22. Okay, yeah, never mind. Limiting reactant pala is PBI2. So follow nyo lang yung nandun sa yung ginawa ko dun sa PowerPoint, which is just converting yung grams of PbNO3 to grams of KI and seeing na mas greater na yung grams ni KI na na-produce for PbNO3. So that would mean na KI is lesser. And next, so from there, just multiply yung mass ni KI na nakuha mo from to its molar mass and then convert it using the stoichiometric ratio of PbI2 and KI, which is 1:2. So, and then after that, you multiply it to its molar mass in PbI2, and eventually you'll get 18.176 or 18.18 grams of PbI2. Check if tama or parehas. Okay, so parehas. So that's all lang naman na problem. Any questions pa ba in terms of solving and yan, any tips on how to solve problems such as these or any others na nakita niyo sa net or sa libro ba? Na naman. So that's kung wala naman, then we're done. Ay ba?